Alright guys, so today's lesson is section 1.3a compound statements. If you think back to compound sentences that you learned in English, you use the words and or to put things together. Same thing applies to compound statements. We're going to use the words and or to combine two or more statements. I will go to school and I will go to Bojangles for lunch. You can make an A on the quiz or you can fail the quiz. Those are both compound sentences. The word and combines two statements in a way that implies that the two statements that are to be taken jointly. Okay? Jointly. What that means is we intend for both statements to be true. So I will go to school and I will go to Bojangles for lunch. We intend both of those things to be true. So R is greater than -5 and R is less than -5. What that means is that that the letter R comes between -5 and 5. Okay, so what that means is this. If you're looking at a number line, let's have -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. Okay, so because neither of these have the equal to, they both have open circles. So it's less than 5 and greater than -5, so it's the numbers in between these two. That's what this means. So what this means is R is both greater than -5 and less than 5. Okay? So the symbol that we use for and, because you know we love a symbol, it's like an upside down V. Okay, this means and. It's the intersection. What they have in common. Okay, so the definition of P and Q, both statements. So this would be like the P statement and this would be the Q statement. So we have two things that's P and Q. So the definition would be the statement P and Q is true when and only when both P and Q are true. Okay, So truth tables are just short ways of making things true and false. So what we would say is this is for statement P, this is for statement Q, and this is for P and Q. Okay, so let's say that P is true. So all the different combinations, P and Q could both be true. P could be true and Q could be false. P could be false and Q could be true, or they could both be false. Okay, so if you just have two things, this is the first two lines of your truth table every time. They're both true. One is true, one is false. The other's false, that one's true, or they're both false. Okay, so remember, in an and statement, this is true only when both P and Q are true. And there is only one line that has them both true, and that's the first line. The rest of these would be false because this is true only when both of them are true. And I'm sorry, my little Venn diagram, my circles really stink today. But we have P, we have Q. So P and Q, if you're looking at it from a Venn diagram standpoint, is the overlap P and Q. So we're looking at it from a statement form, from a truth table form, and a Venn diagram form. So solve and graph the solution set for the absolute value, and you can't see that, I'm so sorry. Absolute value of at x plus 4 is less than 8. Now, if you think way back, how do we solve absolute value problems? To solve absolute value problems, you take what's inside the absolute value bars, and we write it as given, and we write it what was in the absolute value bars, and do basically the negation. So we flip this and change the sign. Okay, so we go to solve this. We're going to subtract the 4. So x is less than 4. And we move the 4 over here by subtraction. And x is greater than negative 12. So it's like the problem we had up here, that x is going to be greater than negative 12 but less than 4. So to graph that, it's going to be a long numbered line. So we'll go negative 13, negative 12, negative 11, negative 10, negative 9, negative 8, negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, and 5. I like to put 1 on each side so that way it's not to the very end. Again, these are open circles. And you color in between them. So the solution set are all the values that are between negative 12 and 4. Okay? So, next, the word or is used in two different ways in English. Okay? You have an exclusive or an inclusive or. Okay? So with or, you can say, you can go to Bojangles or Subway for lunch. Okay? So what they mean by that is It means choose one or the other, but not both. So the reason they use the word exclusive is it excludes one of the choices. You can order chicken supremes or fries at Bojangles. Okay, that kind of or is an inclusive or, which means it includes everything. It means choose either one or the other, or both. Okay, so or can be thought about in the English language two different ways. Okay, so if you need to pause that to write that down, feel free to do so. But in the English language, context helps define the or of the statement. In mathematical discussions, okay, math is not as nitpicky, so the inclusive or is used. Okay? So the definition is the statement P or Q is true when P is true, Q is true, or both are true. So as long as somebody's true or both are true, that's all you need. Okay, so let's go to our truth table here. So we have a P, we have a Q, and we have P or Q. Remember what we have going on. Okay, so we could have both true, this one true, this one false, this one false, this one true, or both false. Okay, the first two lines are going to stay the same, first two columns. Okay, so for or, as long as you've got a T in that line, you're fine. So this is true, this is true, this is true, and only this one's false. Okay, when it says P or, so P can be true. So let's go over here. We got P, we got Q. So P can be true, Q can be true, or both. So it's all the circles for or. Okay, so that's looking at it from statement version, truth table version, Venn diagram. All right, example 2. Let's do this one. So we're going to solve and graph the solution for this, because with or, you'll have two different statements. Okay, so we're going to do x plus 1 is greater than negative 1, or negative 2x is greater than 8. So remember over here, you're going to minus the 1. So this is x is greater than -2. Or, remember when you divide by a negative, let's put a little note here. Flip the inequality symbol when you multiply or divide by a negative. All right, so we have that. So we divided by a negative, so it's going to flip the symbol. It does not change the equal to part, it just flips it. So x is going to be greater than -2 or less than -4. So our number line doesn't need to be very big this time. So we can do -5, -4, -3, -2, -1. Okay, so x is greater than -2. Open circle because it doesn't have the equal. Color in the arrow because it's greater than. Or it's less than -4. So that's what our graph would look like there. Okay, and that one's a really easy lesson for today. Let me know if you have any questions. Thanks.